I'm Manori from Sri Ramakrishna Engineering College, Coimbatore. I'm pursuing second year BME.
Hello, sir. I am Mehimadi. I am currently doing second year biomedical department in Sri Ramakrishna Engineering College.
Hi, sir. I am Mohita Thomas. I am PhD scholar from ICE department in 83.
So we also like to welcome Pandian from scientist from MIT. Yes.
I am Maheshwari, Professor, Electrical Department from National Engineering College, Kovilpatti.
Malati. I am also working in Assistant Professor in National Engineering College, Kovilpatti in the Department of Information Technology.
Hello, sir. I am Vijay Raman, Research Scholar, Saidamal Engineering College, Annam District, Ramanathan District.
Greetings, sir. I am Alphonse. I am from Vellore Institute of Technology. I am a direct PhD scholar there. My current area of research is biomedical instrumentation for wearable technology in clinical grade. That's me. Vellore campus. Vellore.
VIT Vellore.
Good afternoon, sir. I'm Dr. Maithili, professor from Sensor and Biomedical Technology, School of Electronics Engineering, Vellore Institute of Technology, V8. Current research, we are actually working on triple negative breast cancers using dynamic contrast enhanced imaging. Yeah. Yeah,
Hello, sir. Myself, Hanuman. I'm from National Institute of Food Technology, Entrepreneurship and Management, Research Scholar. Yes.
Hello, sir. I'm Naveen. I'm also from NIFTM National Institute of Technology and Entrepreneurship Management. So, Tanjavur.
Hello, sir. I'm Haindavi. I am from NIFTM Tanjavur and Food Technology Department. My name is Nishta. I'm from Pune, Marathwada Mitra Mandal, and I'm pursuing robotics and AI.
I'm in the same department, second year. My name is Netra Aknura from Pune.
Hello, sir. I'm Harsha. I'm from Mahindra University, Hyderabad. I'm a PhD scholar and working on the development of magnetic sensors for biomedical applications.
Hello, sir. I'm Parna, currently pursuing my third year biomedical engineering at Sona College of Technology, Salem.
Captain, sir. I am Nandini, currently pursuing third year biomedical engineering, student of Sona College of Technology, Salem.
Good afternoon, sir. I'm Dishal. So I'm pursuing third year biomedical engineering, Sona College of Technology, Salem.
Hi, sir. I'm Ashwati, and I'm also a student from Sona College of Technology. I'm pursuing my third year at biomedical engineering.
Hi, sir. I'm Kavya. I'm currently pursuing third year biomedical engineering, Sona College of Technology. Good afternoon, sir. I'm Pravina from Sona College of Technology. I'm currently pursuing my third year biomedical.
Hello, sir. I'm Anushri from Dr. NGP Institute of Technology, currently pursuing my second year biomedical.
Hi, sir. My name is Ritanya Ashri, and I am also currently pursuing second year BMB, and I am also from Dr. NGP Institute of Technology. Dr. NGP Institute of Technology in Coimbatore.
Good afternoon, sir. I'm Rakshanayan. I'm also pursuing Dr. NGP Institute of Technology, second year. Good afternoon, sir. I'm Danishri from second year BME at Dr. NGP Institute of Technology, Coimbatore.
Hi, sir. This is Kanimuli Karur. From Karur, M. Kumarasamy College of Engineering and Assistant Professor.
Hello, sir. This is Makanya Devi from the same institution working as Assistant Professor.
Madam, which institute?
M. Kumarasamy College.
M. Kumarasamy Karur.
Sir, I'm Bhuvana, physiotherapist working in NAT hospital.
Hello, sir. My name is Suresh Gnanaratnam. I am a physiotherapist. I am a PhD scholar also. I am doing a PhD in rehabilitation science.
So, Professor Ramana, Suresh and Madam are both of them actively involved in many of our workshops, and they continuously used to interact, and our NAT faculty and staff members are very much fond and favorite of them. Yeah.
Hello, sir. Myself, Madan, research scholar Department of Sports Science, Annamalai University.
Which department, sir? Sports mechanics. Yes. So last time also some faculty members attended from the same institute.
Myself, I'm Harshan from the Dhanlakshmi University. Hello. Hey, class.
Hey, we cannot able to hear.
Good afternoon, sir. I'm Harshan from Dhanlakshmi University. I'm a biomedical student, sir.
Good afternoon, sir. I'm Saini from Dhanlakshmi Srinivasan University. I'm currently pursuing my second year biomedical engineering.
Hello, sir. It's been a warm pleasure meeting you. Myself, Hamshini Karthikeyan. I'm a biomedical engineering student from Dhanlakshmi Srinivasan University.
Sir, I'm Sumaya Rushana from Dhanlakshmi Srinivasan University, Tiruchi. I'm also second year biomedical engineering.
Good afternoon, sir. My name is Tanushree. I'm from Dhanlakshmi Srinivasan University, Trichy. I'm pursuing second year BME.
Good afternoon. I am Pandi Rajan, physiotherapist by education, but I work for Delsis currently, which is a technology-based company mainly focused on electromyography. So I take care of sales. I work as a sales manager for entire South Asia. Thank you.
And they will be showing the presentation. He will be Pandian will be presenting the details, and he will be showing the demo of many of the. See, they are especially they are leaders in this acquisition system, and he will be explaining very good practical exposure experience you can gain from him. Yes.
Not to make more money, but when I did my schoolings or colleges, I didn't have access to technology. So I thought like, let me be a bridge between technology aspect and medical fraternity. That's why I jumped in this role. I started as a like technical guy, then it actually evolved into sales at the end of the day. So I'm here. Thank you.
And especially, I want to add, Professor Ramna, Pandian is actively involved with us. He consistently works for the developments, especially for our department is concerned.
Thank you.
Hello, sir. My name is Kausal Kishore Singh. I am research scholar in Instrumentation and Control Engineering Department of this institute in IT3. Sir, I am working under, sir, my research topic is controller design for non-linear processes.
Ramna, he received Prime Minister Research Fellowship, and he is one among the PMR fellow in NIT.
Hello, sir. I'm Guru Vinay from Andhra Pradesh. I'm currently pursuing biomedical engineering in Dhanlakshmi Srinivasan University. Yes, sir.
Good afternoon, sir. This is Jayant, third year EC from Dhanlakshmi Srinivasan University.
Myself, Dhanush. I am from Bangalore, Nagarjuna College, third year civil engineering.
Myself, S1. I'm from Nagarjuna College, Bangalore.
Which college?
Nagarjuna College.
Myself, my name is Nitish. I am from Nagarjuna College, Bangalore, civil engineering department.
And apart from this room.
Myself, Teju, same Nagarjuna College of Engineering and Technology, Bangalore, civil engineering, third year. Myself, S1, same college.
Myself, Rishik. I'm also from Nagarjuna Group of Institution Technology, civil department, third year.
Myself, Rashmi. I'm from Nagarjuna College of Engineering from Bangalore.
Morning. Myself, Rakesh Kodai. I'm studying civil engineering from Bangalore. Yes, sir.
So I have Asha, Priyadarshini. She is doing her PhD. She is doing her MS by research. Archana, she is doing her MS PhD at NIT Trichy. Ivani, all are our scholars. Hariharan and Patramesh, where are they? So before we start, Kaushal, He's also my scholar. So before we start, please give a huge round of applause because they are all together working 24/7. So as I said, this is the first time I haven't been inside the group, WhatsApp group. I feel everything is good and everything is perfect because of them. Okay, so I like to place my acknowledgement to them. So now I leave the stage to Ramna.
Okay, I won't touch it. This is a pointer. Working, right? Okay. Well, first of all, thank you all so much for coming. Some of you are from Trichy, but many of you came from out of town, right? I'm from Chennai. I heard Salem, Coimbatore, right? Pune, Bangalore. Yeah, I came from Bangalore. I was visiting VIT and Amrita in Bangalore. So yeah. And I was born in Lepakshi. Does anybody know where that is? Raise your hand if you know Lepakshi. Yeah? Yeah. Yeah, Lepakshi is very close to Bangalore. So yeah. So I was born there. So one of my friends from Amrita, he drove me to Lepakshi. So we visited Lepakshi yesterday. Yeah. That temple town, that reminds me of my mom. So I just go there just to be with my mom. Yeah. Okay, so and also a lot of interdisciplinary, right? Many of you are from civil engineering. Yeah, आप लोग क्या कर रहे हैं भाई इधर? Civil engineering. You're interested in biomedical applications, huh? That's very good. Let's give them a big round of applause. I mean, data analytics, biomedical, obviously, right? Electrical engineer, I'm an electrical engineer, so I can relate physiotherapy. Absolutely, you should be here, right? And DELSIS, of course, you should be here, medical instrumentation. But then civil engineering, you know, and I should have brought some film star or something, right? So how do I market my research to you guys? So that's going to be challenging. And also, I heard some of your faculty, right? Can all of you stand up? Faculty, just assistant professors. Can you stand up? Let's give them a big round of applause. Thank you. Thank you so much for coming all the way. And then we had PhD scholars. Yeah, no. Are there postdocs? Postdocs? Please raise your hand and stand up. Postdocs? No postdocs. Okay, all right. PhD scholars. Yeah, can you please stand up? PhD scholars. All right. Thank you so much. Thank you. And then we had master's students. S. Yeah. Okay. All right. And any other master's students? Okay. Thank you so much. Then we had a lot of undergraduates. Yeah. Stand up. And so you're totally dominating this place, huh? Okay. Let's give them a big round of applause. Okay, please have a seat. Please have a seat. And we have clinicians. Yes, physiotherapists. Please stand up. Yeah. So you'll stand up twice. Yeah. Okay. All right. Physical therapists. Give it up. Thank you. And then we have industry representatives. There we go. Okay. Where's your friend? There's another talk going on. What is that talk about? Why are we not attending that talk? Okay. All right. Thank you. Thank you all so much. How many of you have visited Dubai? Anybody visited Dubai? One hand. Yeah. You're from Coimbatore? Coimbatore? Okay. Dubai is close to you, right? Ma'am, you visited Dubai? Because it's close to VIT. Yeah? Okay. So if you ever go to Dubai, okay, you will see there is a lot of new development, okay? And there is this place called Palm Jumeirah, okay? Palm Jumeirah in Dubai. And it looks like a palm tree, but it is all man-made island, okay? It's called Palm Jumeirah. Have you seen that? Yeah, yeah. Okay. And so we went there, me and my family. I have two daughters. The younger one is the boss of the house. Okay. So we all visited Dubai, and we went to visit this place, Palm Jumeirah, and they have a tour. And in that tour, they took us in an elevator all the way up so we can get a glimpse of Dubai. Okay. And so before you get into that elevator, they showed a 2-minute video of how the Dubai that you see today happened, okay? And the sheikh that built the Dubai that you see today, he was inspired by very, very small, tiny thing that you wouldn't even observe, okay? He was inspired by this very, very small thing. When he was a little kid, his parents used to take him to beaches, and in those beaches, he would build sandcastles. That's it. That was his inspiration. And when he grew up, he wanted to build bigger and bigger castles. That's how the Dubai that you see today happened. Okay. The reason I share that example is because you all come from multidisciplinary, right? Right. Going forward, that's going to be the keyword. Okay. AI can do coding. AI can do automation. AI can do mechanical engineering. What AI cannot do is these multidisciplinary activities yet. Okay. I don't know when it will do it. Okay. So the reason I shared that story is because you're all coming from different disciplines. And what I'm teaching here is a different discipline, right? For some of you. Yeah. How many of you know what is a synergy? Right? Say not a lot of hands, right? How many of you know what is a brain-machine interface? Yeah. So some of you, right? How many of you know what is human-robot collaboration? Yeah. Have you worked any projects have you worked on? Human-robot collaboration. Okay, good. Okay. So there's a lot of new words, new things coming at you, but I'm going to keep it as high level as possible so every one of you can understand and take something, right? I loved this morning lecture from the cardiologist. Yeah. Yeah. We all learned something from the talk. I was asking him, is chocolate okay? Because it's not white, right? Chocolate to खा सकते हैं. Things that are white, right? Like sugar and salt. Chocolate to white नहीं है ना. White chocolate, I don't even like white chocolate. That's the point, right? Chocolate should be chocolate. Right? But anyway, I was asking, but we all took something from that talk, right? I hope you also take something from this talk and use some of these concepts in your own research. Okay. All right. And are you going to be through this entire week? You're all going to be here. Yeah. How many of you are going to stay this entire week? Okay. All right. Very good. Okay. How many of you are not going to sleep this entire week? In the class. It's okay. Try. Okay. So try hard not to keep it like that. Okay. I'm not going to put you to sleep. Okay. Okay. My name is Ramana Vinjamuri. I'm an associate professor in computer science, electrical engineering. I have my own lab, which we call it Sensory Motor Control Laboratory. And in the US, there is by design the PI last name, and lab we call it Winja Lab. Otherwise, I had no intention to show name. It just happened. I also direct a center called Brain. I spoke about it right in the morning. So this is a neurotechnology center, and this is a IUCRC. It works directly with industry. Okay. The good thing about this style of centers is my students, they get to work with industry directly. When they're pursuing their education, they work with industry directly. How many of you do internships? Yeah, some of you. Yeah, yeah. You do it outside of your curriculum, right? Right. But I think sometimes some universities have professional school, practical schools, right? Some of the new colleges, they have that format as well. Yeah. And also I'm a director for ICTR, and this is Institute for Clinical and Translational Research. Okay. And this is why I was so happy to see a clinician on the dais, right? Most of the biomedical engineering folks, all the techniques that we're developing, where are they actually going, right? What are they meant for, right? For society, right? For people, right? So can we really, really do something for them, right? So that's the question. And I'm also a visiting scientist at, what is NIH? Does anybody know? What is NIH? In the US, we have, I heard whispers. NIH, it's National Institutes of Health. Okay. And you got that right? Yeah, very good. Okay. I don't have silver coin to give you. So National Institutes of Health, and there are several institutes, and one of them is NIDA. Okay. And NIDA stands for National Institute on Drug Abuse. Okay. So we're also developing some technologies for mental health. And in mental health domain, one of the key problem is drug abuse. Okay. So we're trying to develop some technologies for that. And my home institution is UMBC, University of Maryland, Baltimore County. University of Maryland has 9 campuses. One of them is College Park, and the other one is Baltimore County. That's where I work, and there are 7 other colleges and universities. They're all University of Maryland system universities. Okay, so so this is going to be a 2-part. So who's keeping time? You're keeping time? Who's keeping time? Nobody's keeping time. Okay. So this talk I have to give in 2 parts. I want you guys to tell me when I should shut up. So this timer says it's about 25 minutes, but I didn't talk for 25 minutes, did I? Right? I think it was all your introductions, right? So half an hour more, yeah? After some time, I'll pause and ask you, how many of you are feeling hungry? How many of you are feeling sleepy? So then we can take a break, okay? All right, works, yeah? Okay. Usually in my classes, I remember all my students by names, okay? I'm gonna try that in this 5 days, but it's very, very hard for me to remember all your names, but at least I'll remember the towns that you came from, okay? I'm gonna try hard, okay? Okay, so my lab and I myself, we are interested in answering 2 questions, okay? And the first question is how human brain, which is supposed to be an intelligent controller, right? Human brain. How many of you forget coffee? You buy coffee, but you forget it, right? So we do that too, right? This intelligent brain sometimes does crazy things, yeah? So how human brain, which is supposed to be an intelligent controller, controls human hand, okay? And this human hand, this is probably the best available robot in the world. How many of you agree? Yeah? How many of you have seen any robotic hands? Have you seen robotic hands? Yeah? Okay. Can you name any that you've seen? Name any robotic hand, the company? Hmm? Hmm? Be Bionic? Yeah? Okay, very good. You know how much it costs? That's a good question. Okay. So I can name a lot of hands, but that'll be in the prosthetics lecture. Okay. And then I'm going to ask you guys to guess the price. Okay. That's really, really important because we might make something and then let's say it costs you more money than Mangalyaan. Will anybody buy that? Right? So that's a very, very important problem. Okay, so controlling human hand, and this is a very, very, very complex robot.
சொல்லுங்க
Okay.
சீஃப் வார்டன். ஆமா 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 நான் 9:20 கிளாஸும் 10:30 கிளாஸும் 2 ஹவரும் கண்டினியூஸா. ஆமா இந்த செமஸ்டர் எனக்கு நல்ல ஒர்க் லோட் கொடுத்துருக்காருங்க ஹெச்ஓடி.
Talking about my classes.
அப்படி எடுத்துட்டா
So many
நல்லதுதான் சொல்ல போனா. ரொம்ப கஷ்டமா
boring.
இருக்கு 8 ஹவர்லாம்
Okay.
ஒரு வாரத்துக்கு.
So this human hand, why did I call it and you all agree, right? The best available robot in the world. Why is that?
அப்படிதான் பண்ணணும், வேற என்ன பண்றது?
Why is that? So if I'm writing on a whiteboard, if I'm writing on this, yeah, I'm not going to write on it. I'm just saying, if I'm writing on this, how many dimensions am I working in? Huh? 2 dimensions, right? X-axis, Y-axis, right? That's it. 2 dimensions. Very good. Okay. If I'm walking in this room, how many dimensions am I working in? 3 dimensions, right? What did we add? The Z-axis, the 3rd dimension we added, right? Human hand works in 25 plus dimensions. Isn't it crazy, right? 25 plus dimensions. Okay, what does a dimension mean? They are independent of each other, right? So human hand works in 25 dimensions. And if you add arm as well, you're adding 30 plus dimensions, okay? All these 30 plus dimensions, the human hand, you're able to control this human hand arm with these 30 plus dimensions. You are doing this magically every day. You know, the reason is that how many of you play any musical instruments here? Do you play any musical instruments? Nobody? Yes, yeah. Right, BIT? Yeah. You play? Okay. All right. That requires lots, yeah. Anybody else? Nobody plays musical instruments. Really? Really? Okay. Okay. So what do you play? Piano. Yeah, my daughter plays piano. So when you are playing musical instruments, how many of you type here? At least all of you, right? So when you're typing, right? When you're typing, when you're playing musical instruments, right? You are doing really, really complex movements. Your hand is operating in very, very high dimensions, right? So starting from these simple tasks to very, very complicated tasks, all of those you're able to do with the same hands, the same robotic hands, and your brain is able to control all this. So effortless, right? That is when somebody has like a paralysis or a disease, right? I was sharing you about my mom, right? When somebody has a disease, suddenly that ability goes away. It's taken away, right? How many of you in your family or a neighbor or somebody who has paralysis? Thank God, let's be that way. Okay, I hope nobody has to go through that pain. So that, then you realize that suddenly your robot stopped working, right? Then you realize what you have, right? I'm not going to give you life lessons talk, but then you realize that part of the system just collapsed. Then you realize that how much your hand was doing, right? Imagine that. Even if you didn't get up from sleep, your hand is already going and reaching for your phone. And you got up. What do? The first thing you do is to get up, you have to use your hands. Get up, right? And then you go to restroom. And then you start texting, right? Right? Or you go on news, or you go on social media, right? Twitter, TikTok, right? Everything, right? Did you realize it till today that your hands are doing 90% of your work, right? That's all done by your hands. Of course, writing exams and all that, of course, yeah, right? So those important hands, right? That's why I got interested in this research, is how this intelligent brain is able to control this complicated robot so effortless, right? Mazak bana diya iska, it's like comedy. Such a complicated system. You don't even know how you're doing this, right? When you're playing a piano, when you're typing, right? I mean, we have stopped typing in Microsoft Word, right? We're typing in ChatGPT these days. Yeah. So when you're typing, right? Right. So this is such an important robot. Okay. So now I'm going to add one more question to this, is how this human hand, this is not just a robot. This is a sensory robot. Okay. Now, this is not just a mechanical robot. It has sensors on it. Okay. Can anybody take a guess? How many sensors are in the palm area? How many sensors do you think? How many biosensors sending information back to the brain? How many sensors they may be? Any guesses? There's no wrong answer. There's no silver coins. Forget about it. There's no credit. Okay. No negative marking. Are we keeping any grade? Sabko, everybody passes the course. It's amazing, huh? I wish all the courses were like that. Okay. All right. So how many sensors do you think are in human hand? The palm region. 1,000. Okay. All right. Any other answers? Huh? Billions. Billions. Okay. Any other answers? My favorite civil engineering group there. Any guesses? By how many sensors do you think? Take a guess. There's no wrong answer. Huh? 1,000? Right. So there are 17,500 sensors. 17,500 sensors in the palm region that are sending information back to the brain. Okay. So now how does that work? Okay. How many of you drive here? Drive meaning driving a car, let's say. Drive a car. Yeah. Okay. So those of you who drive a car, okay. Bikers, hopefully, please don't do this. Okay. When you are driving a car, let's say your eyes are on the road, hopefully, not on the phone, right? Your eyes are on the road, right? One hand is controlling the steering, right? And suddenly your cell phone slips out of your pocket, okay? The other hand starts searching for it, right? Right? And it'll get back to you. How many times this has happened for you? Right? So many times this has happened, right? So were you looking? When you were searching, were you looking? You weren't. The hand was. With the sensors on it, the hand was. It was feeling the surfaces, and then it detected a difference, and then it found the object, the phone, and it got it back to you, right? So that is how important the sensation is in this hand. Okay. So not just a mechanical robot, but it is a sensory robot. Okay. So we're interested in understanding how does the hand take all these sensors, all this information, and it is sending this information back to the brain. Now, when you get information, what do you do with it? The brain is acting like a multi-input, multi-output parallel processing system. This is digital, total, right? It's taking all this information and it is making sense of it, right? And making sense of it, and it is giving you commands, right? So this brain and the hand, okay? These two are enough for lifetimes to study, yeah? So this is such an important topic that not only engineers and scientists like us, but clinicians are interested, right? Neuroscientists are interested. Neurologists are interested to solve disease problems with the same equations that we are using. Make sense? Yes? All right. Okay. So I'm going to show you this video. And throughout the lectures, you will be seeing a lot of videos. And so this is modular prosthetic limb, MPL, from Applied Physics Laboratory, Johns Hopkins, which is like 20 minutes from us. So please carefully observe that video, and I'm going to ask some questions, okay? The video has audio. Do we have speakers? We're going to restart. So let's see if that. That's, oh, okay. That's. Okay.
Show the near natural movement of the hand and arm. Now, a normal upper extremity, including the hand and the fingers, has over 20 different ways, 27 different ways it can move. This hand at this point is built to perform all of them. And as you see, it even can move between touch the fingers and to the thumb tip in a way that would allow for great dexterity. Here's an example of being able to pick up an object, move it, manipulate it. One can see the potential with this kind of movement for performing the kinds of activities of daily living that the paralyzed can't do. A person could use this hand to answer the phone, to feed him or herself, potentially even to get out of bed. Now, this may not seem like much what you're seeing right now, but imagine being paralyzed from the neck down, not being able to feed yourself, to be outfitted with this arm, if indeed it proves to be of sufficient safety and effectiveness to warrant getting to market, and allowing someone to take a drink of water, something that people can't do when they're paralyzed. So the potential impact to some very basic human functions that make those who are affected by these disorders feel like normal people is truly phenomenal to consider. Now here's an interesting part. The engineer operating the arm actually makes a little mistake here. See, the wrench drops, and yet the device has enough dexterity to get the prosthetic hand back onto the wrench and pick up an object and perform the function. Now, I'm not suggesting that wrench maneuvering is the critical task that people who are need, but it shows role that this arm prototype has at this point. Now, remember, this is a prototype, and there's still a component of studies that include placing the sensor on the surface of the brain and performing the clinical trials to provide reasonable assurance that that's a safe and effective approach before this would make it to market. But the timeline that DARPA proposes tends to be pretty aggressive.
All right. How's that? Good? How much will you pay to buy that arm? You don't have to know anything. I'm just asking how much will you pay? $1,000, right? Huh? Maybe that's he's being very careful. Okay. You had another answer? 5 crores. 5 crores you'll pay for that arm. But please give 5 crores. I'll take it right up. I see. Okay, good. Okay. All right. Any other on that side? Any other answers? How much will you pay for that arm? Sarah, yeah. 25 lakhs. 25 lakhs. Okay. All right. So that arm costs $250,000. Okay. It costs $250,000. Okay. Somebody do the conversion, please, to INR. It costs $250,000. Okay. So now let's say somebody even built it, right? How many people will buy? I mean, there are not a lot of customers for that even in the US. Okay. If that is the situation, how many of people will buy in India, right? So it is very important for us to build low cost technologies. That's a very, very important design principle that we need to learn, right? Low cost technologies, right? You're building ankle prostheses, knee prostheses. What price are you targeting? How much it will be? Below 3 lakhs. Yeah. Is that reasonable? The insurance pays for it. Yeah. Okay. Very good. Okay. Thank you. Okay. So from the video, how was that arm being controlled? How was the arm being controlled? If you know the answer, raise your hand. So I'm going to pick one of you. How was the arm being controlled? So nobody saw the video? Was it? Yeah. Okay. Okay. VIT. Yeah. Right. Good, very good answer. Thank you. Thank you so much. So that was sensors, not video, right? Not computer vision. It was sensors. So the person was wearing a glove, right? And it's called cyber glove. Okay. It's like a data glove that is recording the movements, right? And they're transferring it digitally. They're transferring this data to control the hand part of the arm. Okay. What about the arm? How is that being controlled? They said it in the video. Okay, I don't know if you're able to hear that. Accelerometers were sitting in different joints, and they were controlling the arm part of the movements. Okay, make sense? Okay, so that is one way to control prosthetics. Okay, you could control prosthetics using wearable sensors. You can control prosthetics, but does that work in all cases? Will people prefer to use like that? Right? They want to use their natural body signals, right? So that is the difference. That is the difference in what we've seen, okay? But that was a cool robot, and it is what is called an anthropomorphic. What does that word mean? Anthropomorphic. Right, right. Very human-like. Okay, very good. Thank you. So it is very human-like. The arm, weight of it, form factor, the joint movement, human-like. Okay? And it's one of the good arms at the beginning. Okay. All right. So 2 questions that my lab is trying to address: how human brain controls human hand, right? And how human hand feeds information back to the brain. Make sense? Yes. 2 questions. So if I have to address these 2 questions, okay, what should I do? If these are the questions that I want to address, what should I do? If I have to come from Bangalore to Trichy, open Google Maps, right? That's the instruction, right? Yeah. Okay, so like that, if I have to answer these 2 questions, what should I do? Okay. Signals. Yeah, okay. Very good. Okay. From brain, from muscles. Huh? Very good. Yes. Fine. Yeah. Okay. Yeah. So why can't we understand nervous system first? Yes. Very good. Very good. Okay. All right. So you want to understand. So all of you focused on biosignals. Yeah. So most of it. What else? Just biosignals that we need to understand. Huh? Sorry. Say that again. Yeah. Yeah. Again, so that's still about biosignals, understanding biosignals, right, man? Yeah. What else? Huh? Okay, converting to biosignals into electrical signals. So you still all focused on biosignals. So there's one student here. She said that understanding the biomechanics, right? And purely focus on the movements, right? So that's exactly what I do, what I did. So I take two approaches. One of them is top-down, so that's what most of you guys said, right? So understanding neural representations of hand movements. So I record brain signals using EEG, electroencephalography, right? EEG stands for electroencephalography. Everybody knows that, yeah? Civil engineering guys, you got it, right? Electroencephalography, right? I'm not picking on you. I'm just, okay? So I don't know how many of you know this. Cephal is the Latin word that comes from that. EEG, encephalograph. Cephal is the Latin word. Cephal in Latin means skull. What is that in Sanskrit? Skull in Sanskrit. You said it. Kapala. Kapala is the word in Sanskrit, right? That is one other way we need to prove that Sanskrit is the mother of all languages. Is that cephal or kapal? That's where it comes from, encephalography. Okay. All right. So electroencephalography, and then I also use EMG, and I'm using your picture, yeah. So you see those sensors. Those sensors are Delsis Trigno sensors. So we have that company here. They record EMG signals, right? Muscle signals, yeah. And also there are other ways to record brain signals by using magnets, right? And we also have some people with that expertise also here, right? We can use scanners, right? CT, right? So so that's another way to record brain signals, okay? So that's the top-down approach I take. The bottom-up approach is understanding the control mechanisms of hand movements. So purely looking at hand movements, okay? So we are purely looking at hand movements and trying to understand how these hand movements are, how do they work, can we understand something from them? And those two approaches, they're totally two different, right? One is purely understanding the biosignals from top down. The other approach is purely understanding movements from bottom up. Make sense? Yes. And it's the same glove in the video. That's Cyber Glove, right? That is also from a company whose CEO from Hyderabad. Okay. So in the beginning of my work, we took objects like that, recognize those objects, right? They're like these play toys, right? Kids' toys. So, but different sizes, different shapes. So somebody will be wearing the glove and they will be grasping these different things. And we are measuring those movements. We're trying to simply understand how those movements are. Okay. No brain signals there. We're just trying to purely understand those movements so we can replicate some of these in robotics, right? Yeah. All right. But primarily trying to understand those two questions that we started with. Okay. All right. Now, these two questions, these two approaches, right? Do they have any applications, or is it just my fancy? Is it just my dreams? Okay, this is beautiful research. I'm going to do this. Does it have any applications? And can you it's the other way. Particular electrical activity triggers a particular movement. But okay, very good. Okay, so it has some use, some connection, right? So what? So I want answers from you guys. Okay, and some of you are answering, but I want more of you guys to answer. Okay, all right. I want you guys to participate in 5 days course, right? And if I'm talking all the time, it doesn't look nice, right? Right. So I want you guys to participate, and it's okay if you make mistakes, right? We'll not take silver points from you, or we'll not give silver points to you. Okay? All right. So no negative points. Yeah. So please participate. Okay. It's okay to make mistakes. All right. Totally fine. Okay. All right. So what are some of the applications of this research? Any guesses? Yeah, please. Exoskeletons or exosuits, right? Very good. And you're from Mahindra. And Rob. Okay. Yeah. You can build up prosthetic for the amputated patients. Yes, so you can build prosthetics, yeah, right? Hand prosthetic, arm prosthetic, yeah. Okay. Any other? Only two applications like suits. Any other applications? Rehabilitation. Very good answers. Okay. All right. So if this is just my dream research, nobody will give me money to do this research, right? Right. So this has two important applications. Okay. So two very, very important applications. And that is in motor control and motor learning. Okay. All right. So these words are going to use motor control and motor learning. Okay. So the first question that we're asking is, can we improve impaired control in individuals with motor disabilities like paralysis, right? Stroke or spinal cord injury paralysis, right? Physiotherapists here. In India, what are the stats? What causes paralysis more? Is it spinal cord injury or stroke? Stroke, you see more stats, right? Same thing in the US. Stroke, you see more stats. Just like our cardiologist in the morning said, right? Avoid the white things, right? Salt, sugar, these two things. You don't need cancers. You don't need dangerous diseases. These two things can kill people. These two things can really disable people. Okay. All right. So can we improve impaired motor control in individuals with motor disabilities? Okay. The second question is augment. Yeah. So that's another item. So augment. Right. So, for example, let's say there are these soldiers who are deployed in very, very difficult conditions, very, very difficult war zones, for example, okay? And they have to carry heavy equipment. Okay? For them, you can design exosuits, but you don't want them to look like Iron Man, right? They should be very easy to use. It should be like your jacket. Put it on, it should be like that, right? So it should be easy to wear, easy to work with. So these are some of the things that we'll be talking prosthetics as well. Yeah. So exosuits for individuals with needs like soldiers. Yeah. Any other examples? Who might need these augmentation other than soldiers? Who else might need? Augmentation. Yeah. Healthcare workers, very good. Like nurses, right? So everybody understands that? Everybody understands? Yeah, that's true. Okay. Logistics. Very good. Two very, very good answers you get. The first one was, what was the first one? Healthcare workers, meaning like, for example, nurses, okay? Nurse practitioners, etc. When they are helping people, right? From bed to up, right? So that's a simple thing, right? But how much weight they're lifting, right? And then putting it down, and you might think, okay, this may get very well, right? But they're doing that 10 times a day, right? And depending on the capacity the hospitals are serving here, could be 1,500, 3,000 times a day, right? Yeah. So very, very physically, very, very demanding job, right? Isn't that yes, agreement? On demand, right? Yeah. And let's say the physical therapist training hand movement rehab. They have to do this type of movements, guided movements, right? And you do that 100,000 times a day, right? So that's extremely demanding on the arm, on your neck, on the spine. Right? You take a move. Okay, so that was one. The second thing that you said was logistics. Yeah. So Amazon has warehouses here. Have anybody visited some of the warehouses? Right? Yeah, we've been there. Amazon warehouse workers. I'm going to do exercises. Just a hand. Okay. Yeah. I'm going to do squats. Yeah, squats, good, right? Right, yeah, that movement. Then these Amazon warehouse workers, they do that almost 1,500 times per day. I do workout, okay, and I do 30 times in my exercise, okay. And the Amazon warehouse workers, they're doing that 1,500 times per day on an average. Okay? And they are walking. They're walking about 10 to 15 miles per day. Okay? So that's the distance they're walking. And that's the movement that they're doing, in addition to several other movements. Yeah. So those use augmentation as well, right? So they also need augmentation. Yeah? So these are some of the really, really important applications. Then second is motor learning. This is very closely connected to rehabilitation, neuromotor rehabilitation, right? So it's not just motor, but it's also neuromotor rehab, right? So this is very closely connected to physical therapy, right? So if you have a motor vehicle accident, for example, and you have some pain in the back, the arm, you go to physical therapy, right? And you go through that rehab. That rehab is learning the movements that were lost momentarily due to a disease or an accident, right? So this is learning. This is motor learning. You're learning those movements. Make sense? Yeah. So it's motor learning. Then the second thing is post-stroke. Post-stroke. Okay. There's only 6 months time where you have to do a lot of practice, a lot of high intensity force, a lot of high intensity rehabilitation to regain movements. There's that limit, 6 months. Okay? 6 months, you call it acute phase, right? And then after that 6 months, slowly transition to chronic phase. So in that chronic phase, a lot of therapists have seen that how much have you do, you don't see a lot of improvement. But the first 6 months is all the training. Okay? So that is really key. So that's why we're trying to target in those 6 months, high intensity, what should be? Okay, so then somebody should study this, right? What should be their focus? What should be our movement focus? So that is the next topic that we're focusing on in motor learning is what should we focusing for this high intensity, heavy speed crash course, what should we be focusing on? Okay. So I do the alphabets of movement. So using those alphabets, can we accelerate movement learning? Okay, for example, you play piano, right? So if I teach you how to play piano in 2 weeks, we'll all be newspapers. Okay, we'll all be making news. Okay? Right? So how can we learn really, really complex movement? Okay. So that's the question that we're trying to address that in application as well. Okay. All right. So So these two questions, two approaches, and two important applications, right? And this all led me to one answer in my career. There are a lot of people, these problems in different ways. But this is one answer that I found in my career is this concept of synergies. Okay? And the synergies is derived from a Greek word called, which means working together. Okay? So you've heard this word synergies, right? Synergies between departments, synergies between faculty students, synergies between countries. This word is used all the time. Okay, so in the the good thing is, let's say there are 100 movements, okay? 100 movements. You study those 100 movements and you get alphabets, okay? A few alphabets, right? So let's say 10 alphabets. From 100 movements, you got 10 alphabets. What is the use of these alphabets? you can use these kind of alphabets to create a lot of movements, right? Not just those 100. You can create more movements, right? So that is just the key concept of this research, right? So not just me, there's several other groups working on this in India and in the world. From several movements, let's say you do 100 movements and I collect all those 100 movements, we can get outputs from those. Okay? Once we have these outputs, we can mix and match them and create movements. Make sense? Yes? All right? Okay. So in this course, I'm going to show only one equation, okay? And in this presentation, I'm going to show you only one equation, and that is this. Okay, great. Okay, great. So it's the perfect time, okay? All right. So when we come back, we're going to look at some of the mathematical representation of these alphabets, okay? And from there, we'll take on to the next section, okay? Thank you so much. Thank you.